Today in section 2.4, we're going to learn more about linear equations. Our objective is that we can write an equation of a line given its slope and a point on the line. Remember from the previous lesson, video 2.3, we specifically focused on slope-intercept form. And remember that when we're given the slope and the y-intercept, we can easily take the m and the b and plug that in for slope-intercept form, which is y equals mx plus b. Today, the first thing that we're going to do is focus on what form we should use when we're given the slope and a point that is on the line, but typically not the y-intercept. In that case, we would use point-slope form. Later in this lesson video, we'll learn about standard form as well. So point-slope form is an equation in the form y minus y1 equals m times the quantity x minus x1. And like I said, you would use this form when you're given the slope and a point that is on the line in the form x1, y1. Before we get started on our first example, I'd like to show you that this point-slope form is actually related to the slope formula that we discussed in the previous lesson video, m equals y2 minus y1 over x2 minus x1. If we substitute the general point xy for x2, y2 in the slope formula, we can rewrite the slope formula in terms of the point-slope form. I'll show you how to work that through right now. So as you can see in the equation of the point-slope form, y minus y1 is all by itself on the left side of the equation. So that's my goal. I want to get y minus y1, that expression, all by itself. So you can see right here that we have x minus x1 on the bottom. So we're going to multiply both sides by that expression so that we can move it over to the left side. From there, the x minus x1 cancels because that's just 1, and then we have y minus y1 all by itself. So the equation y minus y1, just writing it on the left side and switching the sides, is equal to m times the quantity x minus x1. So you can see that it only required basically one middle step to go from the slope formula to the point slope formula. In example 1, we have a line that's passing through the point -5, 2 with slope 3/5. What is an equation of the line? Because we are given the slope and a point that is not the y-intercept, the best form for this equation is point-slope. So first thing I'm going to do is rewrite the point-slope form and also label the given information. x1, y1, and m. From there, you just need to substitute in those given values. So we have the equation y minus 2 is equal to 3/5 times the quantity x minus a -5. Now remember, we can't just keep it like that with a double negative. Double negative gives us a positive, so our final answer is y minus 2 equals 3/5 times the quantity x plus 5. In example 2, we are told that we have a line that passes through the point 3, 2 and 5, 8. We need to figure out an equation of the line in point-slope form that represents these 2 points. I'm going to label the points x1, y1 and x2, y2. Take note that we're not given the slope here, so we need to find that. Substituting the given points in, we have 8 minus 2 over 5 minus 3. That reduces to 6 over 2, which is equal to 3. So that means our slope is 3. From there, we're going to substitute that slope in for the point-slope formula. So you can see we still have the blank space for the coordinate point. Now at this point, it does not matter which point you plug in. You could plug in 3, 2 or 5, 8. It's up to you. Both forms, whether you plug in the first point or the second point, will still represent the same line when you reduce and simplify into slope-intercept form. So both of these equations would represent the line that passes through the given points. Like I said, if you were to distribute that 3 and then add the number next to the y, you would get the same slope-intercept formula. Let me know if you need any more help on the point-slope form. We're going to move on to the other form that we're discussing today called standard form. A standard form of a linear equation is ax plus by equals c, where a, b, and c are real numbers and a and b are not both 0. And when possible, you want to write the coefficients a and b and the constant term as integers. That means when possible, you want to make sure that a, b, and c are not fractions or decimals. If they are, there are a few ways that we can get rid of those fractions or decimals to put it in the correct form. And I'll actually be showing you that process in example 3. In example 3, we are asked to find the equation of the line y equals 3/4 x minus 5 and put that in standard form. And we need to use integer coefficients. So take a look at the standard form above that we talked about earlier, ax plus by equals c. Notice that the x and the y are on the same side of the equation. So that's what I'd like to do first, is move the 3/4 x over to the other side by subtracting. I'm choosing subtraction because it was originally a positive 3/4 x. So now we have negative 3/4 x plus y equals negative 5. Now, it said we need to use integer coefficients, so that means we don't want to have any fractions. And you can see right there we have a negative 3/4 in front of the x. So what we want to do is multiply each side of the equation by the least common denominator of all fraction coefficients. Fortunately, we only have one fraction here, so that means the least common denominator of the fraction coefficients would just be 4. So we want to multiply both sides of the equation by 4 to get rid of that denominator, which is 4. Make sure you share the 4 with both terms inside of the parentheses, and I'm showing the middle work right here. When you multiply, the 4's cancel. That was what we wanted to happen, so we have negative 3x for the first term plus 4y equals negative 20. So that is the equation of the original equation in standard form this time. Originally, we were given the equation in slope-intercept form. And you can see that all the coefficients are integers. So now we have learned the 3 different forms of linear equations: slope-intercept form in the previous lesson video, point-slope form, and standard form, which we're discussing now. This is a really nice way to see all 3 forms discussed, and it also helps you figure out when to use each form. So feel free to pause here to write this down. And now let's talk about standard form if a is 0 or b is 0. If a is 0, then that first term is canceled completely, and then you just have by equals c, which means that you just have y for the variable, and that when y is by itself and there's no x, that's a horizontal line. Remember last video I showed you the acronym HOI VUX. So that helps you remember when you have a horizontal line. If b equals 0, then that means the by term is canceled and you only have ax equals c. And that is a vertical line, because remember, when x is by itself and there's no y in the equation, that is a vertical line. Whenever you're given an equation in standard form, the quickest way to graph is to find the x and y intercepts of that line, plot those 2 points, and draw a line through those points. So that's the quick process that we're about to use in example 4. Example 4 asks us to find the intercepts of the line or equation 3x plus 5y equals 15. Once we find those intercepts, we will graph the equation. To find the x-intercept, we're going to set y equal to 0 and solve for x. The reason why this process works is because at the x-intercept, the y value is 0. So plug in 0 for y, and everything else is the same. From there, you see that the 5 times 0 is just 0, so that whole term cancels. So you just have 3x equals 15, and then divide by 3, and we find out the x-intercept is 5. So in coordinate form, that would be 5, 0. For the y-intercept, it's a similar process. The only difference is we're setting x equal to 0. The first term, 3 times 0 is 0, so that cancels. We have 5y equals 15, and divide by 5, and we find out that the y-intercept is 3. So in coordinate form, that would be 0, 3. So I just plotted the x and y intercepts and I color coded them. The x-intercept is the red point and the y-intercept is the blue point. Now we just need to draw a line through those 2 points and make sure you have arrows at the end. In example 5, we have a real-life application problem dealing with biology. The number of times a cricket chirps per minute depends on the temperature. The number of chirps in 2 seconds for 2 temperatures are shown at the bottom right. First thing we need to do is figure out a graph that models the situation. And in order to graph, we need to identify what our variables are. Our variables are x equals temperature in degrees Fahrenheit and y equals number of times a cricket chirps. I determined which one was which because the number of times a cricket chirps depends on the temperature, and remember, y depends on x. You may have noticed that the problem deals with two different units, minutes and seconds. So this process that I'm working through right now is basically changing the seconds into minutes. So because there are 60 seconds in a minute, we want to multiply the number of chirps in 2 seconds by 60 over 2, or also known as 30. So I'm finding the number of chirps per minute for 40 degrees Fahrenheit and 93 degrees Fahrenheit. I find out for 40 degrees Fahrenheit, the number of chirps per minute is still 0, but for 93 degrees Fahrenheit, the number of chirps in a minute is 240. I plotted these 2 points, drew a line that connected the 2 points, and I made sure that the axes were labeled and the graph was titled. This is what the graph looks like for this situation. Part B asks us to write an equation of the line in standard form, so I'm using the same 2 points as before, and I'm using the slope formula to find out what the slope is, and I find out that the slope is 4.5. Now we're going to use the point slope form, substitute the slope in 4.5 and one of the coordinates. I chose to substitute in 40, 0 for the coordinate x1, y1 just because those are easier numbers to work with. So when I substitute those in and solve for y, I get y equals 4.5x minus 180. Now it asks for standard form, so what we need to do is get the x and y variables on the same side of the equation. I added 180 to the other side and subtracted y, so I got 4.5x minus y equals 180, and that's the standard form. Part C asks us to find how many times would a cricket be expected to chirp in 1 minute if the temperature is 70 degrees. Remember, x stands for the temperature in Fahrenheit, so we're going to substitute in x 70 for x in the equation. You could use either equation, standard form or slope-intercept, but because we're solving for y, the slope-intercept would be quicker. When substituting in 70 for x, we find out that y equals 135. Therefore, if the temperature is 70 degrees Fahrenheit, the cricket would be expected to chirp 135 times in 1 minute. Okay, now we're going to talk about how slopes can help us determine how lines are related to each other. So the slopes of two lines in the same plane indicate how the lines are related. Now there are two special relationships. The first one we're talking about is that of parallel lines. And you need to remember that parallel lines have the same slope but different y-intercepts. So they're going up and over at the exact same rate, but they are not intersecting at the same y-intercept, because if that was the case, then they would be the exact same line, and therefore they wouldn't be parallel to each other. The other special relationship is that of perpendicular lines. Perpendicular lines, hopefully you remember from the past 2 years, Algebra 1 and Geometry, perpendicular lines intersect at a 90-degree angle, therefore they cannot have the same slopes. In fact, they have slopes that are called opposite reciprocals of each other. And they could have the same or different y-intercept. That part does not matter. So opposite reciprocal slopes. This is sometimes a confusing subject for some people. So let me just give you a quick example. Say, for instance, the slope of the first line was 2. Technically 2 over 1, the slope of the perpendicular line to that first line would be that of negative 1/2. The way that I got that was I made the positive 2 a negative 2, that's the opposite, and I took the reciprocal, aka the flip of negative 2 over 1, which is negative 1/2. Here's our last example of the lesson. We need to write the equation of each line in slope-intercept form because that's the easiest form to graph. Our process will be first identify the slope, second use point slope form, and third rewrite in slope-intercept form. Part A, we need to find the line parallel to y equals 6x minus 2 through the point 1, negative 3. First thing, I know it's parallel, so that means the new line is going to have the same slope, which is 6. So I substitute 6 in for m. I also label the coordinate point that we're given, which is 1, negative 3, so that's x1, y1. I substitute that point in for the equation. I simplify, and I get y equals 6x minus 9 for the first equation in slope-intercept form. Part B, we need to find the equation of the line perpendicular to the equation y equals negative 4x plus 2/3 going through the point 8, 5. First thing, we need to identify the slope. The slope is 1/4 because we know that these are perpendicular lines, and perpendicular lines have slopes that are opposite reciprocals of each other. The opposite reciprocal of negative 4 is 1/4. So from there, I substitute in 1/4 for the slope and the point 8, 5, reduce that, and I get y equals 1/4 x plus 3. Here are the problems for the 2.4 lesson check. Make sure you write them down, complete them, and let me know if you have any questions the next time we see each other.